What I'd like to introduce is our keynote speaker this morning, Professor Brian Collins, who's Professor of Engineering Policy in my department at UCL, and he's also Director of the International Centre for Infrastructure Futures. So over to you, Brian. Thank you.
Morning, everybody. Make sure this works. So, Tomorrow's World, not a TV programme. And some of you will have seen a diagram like this before. It's a cone which describes possibilities, probabilities, preposterous ideas, and possible projected futures. And it's a way of examining how to look at the ideas that you might have against a range of different timescales. And that's going to be the theme of my talk, is the range of different timescales we have to consider in thinking about futures and how they interact with each other. There's an old Soviet proverb, which is to say, the future is certain, you can rewrite the past. Some of you may have picked up a headline this morning that about to be President Trump has now rewritten his past by saying climate change is for real. If you haven't picked that up, that's pretty amazing, given what he said 10 days ago. So you can rewrite the past in North America as well as in Russia. So this is a way of examining, as I've said, different timescales for the future. So one of the sets of timescales I want to use are those which are to do with this list of topics. And I'm not going to read them because you can read quicker than I can say them. But you can see that some of the things you have to worry about that happen in microseconds or seconds can interact with those things that take minutes or hours, and entrain those things which take years to decades. Taking the autonomous vehicles example, for instance, we have vehicles at the moment which are designed so that people can travel safely in them. In other words, they don't have G-forces applied to them, which they couldn't cope with satisfactorily. Now, if we go to a situation where I summon a vehicle to come to me with no one in it, then the dynamics of that vehicle during that part of its journey can be different from what it would be, and hopefully would be, when I'm in it. Now, that will change the way in which a vehicle behaves on the road. There are things that you can do with a vehicle on the road with a person in it that we would find unacceptable, but without a person in it, you can do much more difficult things. Now, if you think that is something that we don't have the technology to enable, I'm old enough to remember in 1973 when people said Heathrow's full, we're landing an aircraft every 5 minutes. We still have the same number of runways at Heathrow. We're now landing an aircraft every 45 seconds. Heathrow is still full. I don't doubt we could squeeze another 10% out of that and land one every 40 seconds, and then we don't need a runway for a bit longer. So there's an awful lot that technology can do. And in that instance, it's the technology of the aircraft, the air traffic control, and the organisation of the data about what is happening in the airspace and the ground space that allows those sorts of advantages to appear. Now, if you start doing that on the roads, because most of the roads in this country are empty most of the time. Why is that? Well, because we don't organise road transport to use the road space more effectively than we currently do. So we could do that if we had much better data. So that's the interaction between things that are maybe seconds and minutes and those things which are days and years. So I just use those two as examples. And therefore, you have to worry about the way in which the dynamics of the vehicle are organised, the way in which vehicles themselves are organised, the way in which sets of vehicles on roads, and I'm using the roads as an example, but of course it applies in all the other transport modes as well. And therefore, what happens when you've got large fleets of vehicles, in this case a real fleet, and indeed what happens when you do that in an integrated way on land, air and sea, preferably in an integrated way. I was listening to the chief executive of Liverpool praising the fact they just opened up Liverpool Port to take the largest container ships. And then we said, what have you done with all the road transport that lies behind it, or even the rail transport that lies behind it? Of course, that's outside Liverpool's control to do anything about it. They can plead with the government to do something about it, but it hasn't happened. So suddenly you're going to get many more large containers coming off the docks in Liverpool, and where are they going to go? Of course, the same thing has happened in other ports in this country, and we have that problem. So we do need, therefore, to have a much longer view of what the strategy should be for integrated transport, taking account of all of these developments. That happens to be the Gold Coast in Queensland, because if you look around the world's literature, you'll find all the big urban conurbations are now beginning to understand they need to do integrated planning and modelling from what you can do at a vehicle level, at a platform level, in terms of its dynamics, right the way through to what you need to do in terms of infrastructure, industry strategy, education over a period of decades. So I'm going to pick on each one of these very quickly. You can see the sorts of technologies and processes that are needed in the left-hand set of words, and I'm just going to illustrate them with some diagrams to show the systems engineers in the rooms in this particular instance that these are the sorts of things that someone who's worrying about the dynamics of a vehicle has a systems engineering model of how the vehicle works. And in there, you won't find many references to people, because that's all about the dynamic or behavior of the vehicle way within the reaction time of a person. But if you're talking about a train set, then the train set has to have also an organizational process within it. And most of us now are experiencing when the driver says, sorry, I've just got to turn everything off and reboot the train, because actually it is a computer or a set of computers that occasionally, just like your own, needs rebooting occasionally because it's just stopped. And that is becoming a systemic problem, that we need to understand how all of those failure modes affect the resilience of the journeys and the transport experience. Because as we move to more data-driven and automated process that underlies, then we need to understand and model all of those automated processes and what their normal and failure modes might be going forwards. And it's one thing to put in AI. Of course, AI is a learning process, and that means it becomes a lot less predictable in a modeling sense. And once you embed that in everything you do, then you've got a much less predictable modeling concept. It's less systems engineering, it's more systems thinking. And that's, of course, the standard systems engineering V diagram. And, of course, it gets a lot more complex once you start looking at a much more integrated set of activities. So the modeling of operations at a higher and longer timescale is, first of all, you have to worry about normal operations. And that, of course, is now where a lot of activity is going on in order to expedite the value that can be extracted through intelligent mobility and through mobility services by having a much better model of what normal operations looks like. And there will be experts who will talk to you about that all day. However, you also have to worry about the abnormal situation of moving things around which it wasn't normally designed for, because we all know those can really disrupt your life. Actually, the infrastructure people are beginning to realise when it's a big bit of infrastructure like that, maybe we could manufacture that in a way where we don't have to transport it. So on-site manufacturing of large infrastructural components is beginning to be something that's being looked at. It's not only cheaper, it's much less disruptive to society. But then, of course, there are critical services that have to be looked at, and that's an example of that area. We also now, of course, want predictability. We, as citizens, want predictability, because the modelling isn't only about the transport of goods and vehicles, it's about the transportation of us as individuals. So we want this stuff, and we're, of course, getting it, and all of you will probably have an app, which you may have despaired about this morning if you were delayed, which for once I wasn't, which was fantastic. And so you expect to find real-time data which is accurate, predictable, and have high integrity, and you don't know where it comes from. You may not care where it comes from. Actually, in this room, people probably do care where it comes from, because you're the people who write the apps and provide the data sets. So this idea that predictable data helps deliver predictable journeys is really important, for not only for us as individuals, but for operators of time-dependent services, in particular supermarkets with frangible goods, etc., etc. I've left that link down there. I'm not going to operate it. It actually is a link. You'll get these slides. So it's a link to a visualization of the air movements around the planet. There are a lot of things on YouTube. I just picked on one. But they're great fun to look at. But when you look at the complexity of air traffic control and air traffic management in and around our urban airports, you realise we don't do anything like as complex a system management job on other modes of transport as we do in air traffic control. Terry mentioned cross-sectoral learning, and I think that's one area where we could do a much better job, because they've had to do it because it's safety critical, it's mission critical. Of course, the times and spaces are different, and they've got 3 dimensions to play with. It's a very well organised 3 dimensions, and you're very glad that it is. Management of the modelling the management processes of transport, because that's one further layer out. It's not the operations, it's the management of the operations. Demands an awful lot of information management. An information management doctrine, which is being applied in lots of other areas of the world that work well, is not as well applied in my experience. For those of you who don't know, I was the Chief Scientific Advisor in the DFT, and this was one of the areas that we tried to get much better organised and failed, mainly because of the fragmentation of the organisations that are responsible for various bits of transport. Getting them to work and talk and even better listen to each other was damn near impossible, and still is. However, if we're going to deliver intelligent mobility and mobility as a service in dense urban environments, a lot of organisations have got to start collaborating deeply in order to deliver outcomes which we all want. And that, again, is just a simplistic diagram of how the infrastructure and the vehicles of all the various sorts need to talk to each other and listen to each other, let alone the people. Again, in air transport, because it's such an efficient system, that has already happened to some extent. So there's a lot of learning, I believe, could come out of the air transportation systems. When we get to organisations, which is a further layer on, then we end up with assessment mechanisms, and some of you will chuckle as soon as I say economic appraisal, because you'll know how difficult that is, and actually how simplistic a lot of the economic appraisals have been up to now. Modelling the economics of transport system, of course, academically is a hugely important subject, and a lot of economists spend their lives doing it, somewhat detached from the real world of what real transport systems interacting with each other are about. So a lot more appraisal of the transport options into the future, and of course this is further into the future, based on much better data, much better assembly of the models and the reality of the models, is something that we now can do. And indeed, colleagues at UCL and in other universities at the moment assembling a very large program to start exploiting our supercomputer capability, which has not been used in this space, to bring that online to wherever, including here at the Catapult, to start doing very large-scale modelling of what I would call multipolar modelling, in other words, looking at all the factors together as best one can with lots of different types of modelling to do that sort of federation, not necessarily integration, federation of data and modelling techniques in order to deliver much better appraisal of the economics and the operational impact of the way in which we look after our transport systems. But if you don't do that in a way where you have a person who, as it were, looks after the big picture, and in this country we do not, because we've privatised, devolved and separated out lots of different elements of transport, we end up with, although I've written this as a neutral one because it's not the UK, a commissioner for transport, there is no one who actually owns the big picture, has the authority over the big picture. And without that, it's very difficult to deliver an overarching strategy at any sort of national scale. So should we be trying to do modelling at a national scale? Question. Is that useful? What elements of transport is it useful to do it at that sort of scale? None of what we do, of course, is on a green field. At best, it's on a brown field. It's very, very rarely on a green field. So we have legacy to worry about. And we have to understand what the purpose of our transport system is. In certain parts of the world, we don't see this in the UK, at least I haven't, but it's very, very, very common in lots of other parts of the world. No one designed the truck that's underneath that mob of people to do that, but it's being used for that. So we're repurposing vehicles, we're repurposing transport systems for different areas of activity. We've repurposed our railway system extensively in the last 150 years, but we actually haven't done very much to the underlying infrastructure that sits below it. So modelling that and making it useful for the future is actually a major research activity which I'm involved in, because a lot of the way we originally built our railway systems, 40,000 miles of it, is still on the bed, the basic track bed that was built by the Victorians for steam trains that went relatively slowly and not very frequently. We're now building high-speed, heavier, much more frequent trains, and we're still putting it on not exactly the same bed, of course, but underneath it's exactly the same. So we have a planning process, do we? We have planning. I'm not sure it's a process. And so we have to worry about whether that is, as a modelled activity, is as effective and efficient as it could be. And then we have this old cost-benefit analysis curves, which we all use and hate because we haven't thought about doing it any better. But now we're beginning to realise we can do it a lot better because we have a lot more data and a lot more information about how to do things. And at the end of the day, this is as much about people. I recognise it's about freight, but it's also about people. One of the pieces of work I've been doing with Nick Tyler, one of my other colleagues at UCL, is to look at the interaction between the internal furniture of an underground train and its viability as a revenue generator. And you think, what? Where the grab holes are affects how quickly people get on and off an underground train. If they don't get on and off quick enough, you don't get enough revenue out of the fare-paying passenger. We know that if you can do that effectively, you can save one train, which is £30 million, or you improve the revenue that comes from the trains you do run. Done the same thing with Thameslink. Londoners will recognise mind the gap as a phrase. Minding the gap is actually a very important parameter as to how quickly people get on and off trains. And that really does affect the revenue capability. A high throughput transit system also depends on high acceleration. And increasingly, we've got a mixed community on those trains, which we didn't used to have. In particular, we have children. Those of you who have young children will know that their hands are a lot smaller than yours. And that you will look at a grab rail in the underground system next time you travel and think, could my child hang on to that pole, which is what an adult is expected to hang on to? And the answer is no. And if they're not hanging on to something when that train takes off, they become a missile that goes backwards down the train. That is dangerous for the child, it's dangerous for everybody else. It's not too difficult to think of changing that grab pole to make it smaller at the bottom. It's not a structural element, it's there so that adults can hang on to it. You don't hang on to it down there, and yet it's the same diameter. How is that? That's just lack of thinking of how the infrastructure in our transport systems and the lack of modelling of those transport systems affects the diverse community that we now are asking to travel on them. And I just couldn't resist this particular picture, which is to do with resilience, because if you look at the words on the placard above the Gulf station, first of all, Gulf has all sorts of other meanings to do with the gaps between the various elements. Cost cutter, yep, we get that. Lotto, yeah, it's that too. And of course, it's an off licence. And what we have is a Jaguar Land Rover Defender, which everyone knows is the most resilient vehicle for driving through floods. So I couldn't resist having that picture to show you that actually there's all sorts of things that affect resilience that we haven't necessarily got in the right place. Just to finish, the modelling strategy that we have depends upon what the purpose is. If you don't understand the purpose of what you're trying to model, then you're probably not going to model it very well. And those words are just a wordle taken out of a strategic document for transport. And you can see that all those things are possible things you might have as your purpose. But if you don't understand how you contribute to all of them, not necessarily focus on any one of them, but contribute to all of them, then you won't model things in an appropriate way. Energy is a really important element, and yet it's rarely modelled concurrently with transport. We all talk about low carbon transport. What the impact is going to be on our electricity supply if we go for very large-scale electrification. We all know that that is likely. What does that do to the tax revenues is an interesting concept when you realise the Treasury takes £30 billion a year out of the petrochemical industry taxing the fuel we put in our current set of vehicles. So energy modelling and transport modelling are really quite closely interlinked and should be more closely interlinked, but they're not. And that is, again, a plea for the modelling of transport to be put in the context of modelling other areas of activity, and indeed in an international sense, how our transport policy affects others, because we're a trading nation. It would appear we're going to become even more vigorous as a trading nation, in which case we've got to understand how we transport our goods and services, not all of which can be carried digitally. And of course, we then have to worry about what the impact will be of technological innovation as well as process innovation in delivering some of these things. There's a gap between the modelling at microscale and a gap at the macro scale. And it's that meta level of interaction, which is hard, but we're now beginning to understand how to do it, that we need to do a better job on. And this is, again, an air transport example where it's fairly clear where the gap is and what the data needs are. It's much more complex on surface transport because you've got such a different mixture of modes of vehicle and purpose. So we have this various things you can do with modelling. Are you doing discovery? Are you exploring? Are you mapping what you currently know and what you want to have as future scenarios? And by the way, there's creative people around who will disrupt what you want to do by inventing things you hadn't thought of, like the internal combustion engine or the jet engine or hydrogen fuels in a safe way. All sorts of things are going to come along and cause a lot of this landscape to change all the time. So you have to stay awake to all of that. Then there's a reaction to what you do with a model. A lot of people still sort of put their head down and say, the model said do this, so I did. And one of my jobs as the CSA and DFT was to challenge that vigorously, because quite often the model just wasn't common sense, because it had made assumptions, it had made simplifications to make it a tractable model, and actually didn't deliver anything useful. So one of the things you need to do is be sceptical, not cynical, sceptical about whether the model is actually delivering what you'd expect it to deliver. We also have to worry about risk. Our Victorian ancestors took huge risks with our transport infrastructure, and we benefited hugely from that. because they put in a massive amount of transport infrastructure, invented loads of things, not just in this country, in the back end of the 19th century, and we are still benefiting hugely from that. But our management of risk now is much more complex and it's much more constrained by lots of regulation. We also like to do things in a very organised way so that we can have contracts and we have accounting practices and we can have metrics. Now, are they actually useful? Are they delivering outcomes which help deliver transport as we would like to have it? Or are they there as a means of bureaucratic process to protect that someone else's backside is being looked after properly? And this is a map which came from my colleagues, again from UCL, of what the people do and what the people are saying. These are Twitter maps of an element of London transport, which shows how vigorously people are using digital and social media to say things about the transport systems. And much to my surprise, it's all around London Bridge and Victoria and King's Cross. Well, Londoners will recognise why that is. So, just to provoke some thought, understanding the purpose of the model. I've said that. What's it going to be used for? Is it going to be used for understanding? Is it going to be used to deliver options, for consideration, for investment or discussion? Is it going to make predictions about what the future will be? Or is it actually going to be directly in support of operational decisions or even investment decisions? If you don't understand the purpose of the model, you'll most likely use the wrong model, the wrong tool to do the wrong job, and you won't end up in the right place. And don't say you need to do, that's not an either-or list. You can do all of them, but make sure you know you're using the right tool. What we are beginning to see already is social sciences and system sciences coming together in one model, mainly through agent-based modelling and the use of AI, but that is going to change and become done at scale, hence my multipolar modelling, polar meaning multi-everything you like. And that's why we need very large computing, and that's why we've started to get a process of getting nearly £10 million worth of supercomputing available to us from the STFC operation up at Daresbury, but get that online and available. Faster than real-time prediction. What I mean by that is, can you get the data out of what is happening in real time and then predict what is going to happen in the space that is interesting? I know that is happening in certain areas in transit, but it's relatively simplistic. If we start doing that in much more complex environments, then that could really change some of the activity that we can model. Again, air traffic control is close to being able to do that, but it is in a very tightly constrained and regulated environment. But nevertheless, there's the tools there. And Terry's already mentioned 3D immersion visualization. That is going to become much more systemic and available, and that will help people understand what it is we're talking about by way of futures. The requirements for all of this are data, 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 data. Without good data, high integrity data, data where you understand the provenance. Where did it come from? Do we know what it meant? We need to reward people for doing multidisciplinary modelling, and that in a university is a really tricky thing because you need the social scientists, the anthropologists, the economists and the systems engineers to all be rewarded for publishing joint papers around things which normally they wouldn't be allowed to do and they wouldn't get any award for doing at all. And of course cross-sectoral learning, which implies teaching programs in universities and schools, as well as in professional institutions such as the Catapult. And certainly I know from my interactions already with the Transport Systems Catapult, you're already starting to on that process, not only with the placement of students in universities, but also the events such as this that you're holding. So just to provoke some thoughts for our discussion session later, and yes, there is a light at the end of the tunnel. That's a Victorian tunnel, and we've still got it, and we still use it. Thank you.